Hey, ocean travelers around the world. This is the Great Blue Hole, a vertical portal into Earth's past. A perfect circle in turquoise water hides an ice age cave, toxic twilight layers, and a living archive that reads our planet's past and future. The water looks playful on the surface, soft and tropical. But the camera of the mind drops from bright reef shallows to a sudden clean edge where the seafloor stops pretending and falls away. The rim is a necklace of coral, alive with flickers of yellow and silver. Then, with one glide, the world turns cobalt. The circle is so tidy, it feels drawn with a compass broad as several city blocks, deeper than most towers are tall, and quiet enough that bubbles sound like small stones in a fountain. The sunlight thins with each meter, and color slips off the scene the way a coat slips off a chair. Reds first, then oranges, then the rest, until blue holds the frame. It's a free fall through time, and it comes with an honest question. Why does this hole exist, and what does it guard in the dark? The descent continues, easy, steady, like drifting down an elevator shaft, with the doors open. Temperature cools a notch, not shocking, just a gentle reminder that depth edits heat. The surface noise fades, reef chatter becomes a faint hiss. The wall beside the descent is limestone, pocked and sculpted, a cathedral wall carved by water that knew exactly how much patience it had. Then a shape, a tooth of rock pointing down, then another, then dozens, like a forest of stone icicles frozen in mid-breath. Stalactites appear out of the blue like a skyline seen at night, proof that this was once a dry cavern breathing air, not water. The vertical portal metaphor snaps into focus. The present ocean is simply the ink filling the margins of a much older story. Quick fact: limestone forms from the remains, ancient marine life, layer upon layer, compacted over time until it's soft enough to carve and hard enough to hold shape. Rainwater picks up a whisper of acid from the air, and the soil, that tiny acidity, is a locksmith. It finds hairline weaknesses and widens them grain by grain, decade by decade. In places like this corner of the Caribbean, where the platform is a table of limestone, the locksmith has had geologic ages to work. It sculpted passageways, chambers, and massive rooms when sea level stood lower and the sky touched these walls. When the ocean rose again, the locksmith's empty hallways flooded. Caves became underwater, a roof gave way, the ceiling fell, and a sinkhole formed with a mouth nearly circular because geometry loves balance when stone collapses in layered stacks. This hole is a memory turned inside out. Watch out for this. As the descent goes deeper, light doesn't fade evenly. The blue holds longest because water eats red first. That's why a diver's red glove looks gray at depth, unless a lamp returns the lost wavelength. Here, that simple physics turns the blue hole into a natural mood switch. Bright rim, moody center, shadowed base. And on the way down, a person can feel the slight glassy shimmer where waters meet, a halocline. The zone where water with slightly different salinity rubs shoulders, then a thermocline, where temperatures shake hands but don't fully blend. Each feels like moving through a soft, invisible curtain, a brief ripple across the skin and the eye. Before you get comfortable, take a moment to like the video and subscribe, but only if you really enjoy and want to fall asleep with ocean stories whenever you want. The story picks up right where the descent left off, because the next layer is the most surprising, the toxic twilight. There is a pale, milky fog deep inside, a layer that looks like a low cloud trapped underwater. It's hydrogen sulfide, a natural chemical that can be harmlessly distant but becomes a problem for lungs and gills when concentrated. Above this layer, reef life patrols and grazes. Below it, the rules rewrite themselves. Oxygen thins. Fish avoid it. Microbes love it. It's not a monster zone, it's just chemistry declaring its boundaries. Imagine wading into a thick morning fog where your flashlight beam becomes a short spear. That's how this layer behaves. It eats light, flattens contrast, and makes the world feel close. Below the cloud, the quiet is almost absolute, and the rock holds shapes that look like doorways to no particular room. Let's go step by step and trace how this portal came to be. Picture the world during the last ice age, not as a wall of frozen white everywhere, but as an era when massive sheets of ice sat on continents, and a huge chunk of the planet's water was locked up as ice. Sea level was lower, tens of meters lower, so places that are now submerged stood dry or nearly dry. Here limestone sat in the sun and wind, and rain soaked through it. Underground rivers ran through caves, dripped from ceilings into stone bowls, and left thin mineral skins that hardened into stalactites and stalagmites. Those stalactites grew like slow-motion icicles for millennia in air. When the ice age retreated and seas rose, these dry caves filled. Some ceilings were strong, they stayed intact. Others had flaws, they collapsed under their own weight, pulling rock into the void and making a sinkhole with big shoulders and a smooth, almost perfect rim. That's why the hole is so round. It's gravity doing what gravity always does, averaging the rips and tears into a circle. The geometry isn't a party trick. The ledges that ring the hole at certain depths are hints about the cave's original floors and balconies. The mouths of side caverns open like windows. Overhangs hang like frozen waves. Divers who have the training to enter those overhead spaces walk a line between wonder and discipline, because silt waits on the floor like snow in a quiet alley. Kick it, and the world becomes a white room. That risk is part of the architecture here. The blue hole is beautiful and honest about its boundaries. The anatomy of this place reads like a layer cake of worlds. There's the sunlit rim, where corals spread plates and antlers, sponges pose in colors that pop, and nurse sharks nap under ledges. Parrotfish chew dead coral into sand finer than sugar. Schools of jacks orbit like coins in a clear charity funnel. Then the vertical shaft begins, and the wall grows bare and pale, with sponges spaced out like punctuation marks. The water at first is clear, like empty air. Deeper, the halocline or thermocline can show itself as a faint blur, a mirage line. Then that hydrogen sulfide layer creates a gray lid that says gently but firmly, different rules below. Above it, oxygen supports familiar reef life. Below it, life makes other deals, microbes forming mats, threading energy from chemical reactions, building a food web that belongs to the dark. There's a clock in these rocks, and it keeps time without ticking. Every stalactite carries a diary. It grew when water dripped from a cave roof into air, leaving a thin ring of minerals, calcite. Mostly, as the drip continued, ring layered on ring like tree rings. Those layers trap clues about the air and the water from the day they formed. How wet the surface was, what minerals dissolved in the drip, what isotopes of oxygen were present, and how quickly the drip flowed. In a lab, scientists read those rings with gentle lasers, precise drills and mass spectrometers, pulling out timelines of wet periods and dry periods, cool stretches and warm bumps. Some layers are thicker, some thinner, some shift subtly in chemistry. With careful dating, using the natural decay of uranium to thorium, for example, the chronology snaps into focus. This ring formed when the cave was dry. That one stopped when the sea returned. Speleothem stalactites and stalagmites become time capsules, and the blue hole becomes an archive that remembers even when nobody was here to write it down. Sediments at the base tell a parallel story, a softer record written in grains. After storms, a slightly coarser pulse might settle out. During calmer years, finer dust drifts in piles, layer upon layer. Tiny shells and microscopic bodies, microfossils arrive like postcards from the open sea. The mix measures wind, rain, hurricane tracks, droughts, and far-traveled dust plumes. In the lab, cores pulled from the floor are read like stacked pages. Quick fact, some layers even hold hints of wildfire ash blown in from distant land. When those clues line up with coral growth bands on the nearby reef, with cave records from the mainland, and with ice cores from faraway poles, the same beats in climate echo across archives, like a song recorded on different instruments. That's how confidence grows. Multiple records, same rhythm. Humans found this place first with eyes from boats and canoes. For local seafarers, the reef was a map long before any map was printed. In coastal cosmologies, caves and waterholes mark entrances to underworlds, places where spirits travel or where the earth breathes. Respect sits at the center of those beliefs. Approach carefully, know the water is alive. As charts improved, lighthouse keepers and captains marked the Atoll's lagoon and the distinct dark circle in the middle of a bright sea. The blue circle became a landmark you could recognize from a mast, then from a seaplane window, then from a satellite photo. Each step changed how the world saw it, but the whole didn't change for anyone. It simply waited. Exploration arrived in waves. Early scuba expeditions turned a mysterious dot on a chart into a three-dimensional place in memory. In the early 1970s, a famous ocean explorer brought a ship with cameras, compressors, and a sense of showmanship, and the site stepped onto a global stage. That visit did more than film shadows. It proved to a wide audience that this was not a danger trap, but a geological wonder worth studying and protecting. Later, technical divers mapped ledges and cataloged stalactites. In the late 2010s, modern teams returned with submersibles and multi-beam sonar, flying over the hole like slow outer space craft and stitching together a high-resolution model of the shaft, the ledges, and the interior cloud. One pilot described the lower realm this way: "It's like driving into a minty fog where the rock appears at arm's length." The public learned something simple and useful from that work. Beauty doesn't end at the surface, and wonder is a renewable resource if handled with care. Tourism followed that attention. Boats began running day trips from quays and coastal towns. Liveaboards added it to their itineraries, building a rhythm: a pre-dawn departure over clear water, a briefing on the deck, then a calm, organized entry. The site became a rite of passage for experienced divers. Ask 10 of them about their first view of the rim from below, and 9 will describe it like a full moon seen from a valley, long, curved, and impossibly clean. With visitors came a safety culture: depth limits, buddy checks, gas planning, training standards, and strict advice about the overhead environment. When incidents happened, and in any adventurous activity, a few do, the community adjusted. Briefings grew clearer, operators set firmer minimum certifications, guides doubled down on staying with their groups. That's how good places stay good. They teach as they entertain. The science toolkit here looks like a toolbox built over decades. Sonar. First, multi-beam systems send out fans of sound that bounce off the walls and floor, timing their return to build a 3D shape. Think of it as underwater echolocation scaled up. That data becomes a digital model you can fly through. A map that shows where the ledges really sit, how smooth the floor is, where overhangs bite into the shaft, and where side caverns open. Then come cores, long tubes pushed gently into sediments, carefully capped and taken to labs where the layers are sliced and analyzed like a cake cut into thin, identical slices. Speleotheme sampling follows the strictest ethics. A few pieces taken only where they answer a real question, and where the loss is acceptable, often from fallen fragments rather than living formations. In the lab, radiometric dating anchors time with uncertainty ranges, because honesty in science always includes a confidence interval. Stable isotope analysis of oxygen and carbon traces, temperature and rainfall patterns. Trace elements whisper about seawater chemistry and dust sources. The records from the hole are then compared to coral cores from the barrier reef, to cave records inland, to lake mud, and to high-latitude ice. When spikes and dips line up across these archives, the narrative gains strength. A drought here, a wetter century there, a stepwise sea level rise that matches the drowning of coastal caves. Life divides here into two neighborhoods that share a postal code, but not a lifestyle. On the rim, the coral reef is a city. Corals are the architects, building homes of limestone. Sponges are the filters, pumping water day and night. Surgeonfish and parrotfish are the gardeners, trimming algae so it doesn't smother the builders. Sharks cruise like shy patrol cars, often the curious but cautious reef residents. Common visitors include Caribbean reef sharks that drift by with cool detachment. Turtles sometimes graze on seagrass nearby and pass over the rim like gentle blimps. Everything is traffic and routine, sunlit and busy. Inside the shaft, the party thins. There's little to cling to and little to eat. The wide wall hosts a sparse cast. A few wire corals, solitary sponges, an occasional free-swimming visitor slipping in from the open sea and out again. Energy changes form below the cloud, where sunlight can't drive photosynthesis. Microbes run on chemical gradients, turning hydrogen sulfide and other compounds into the currency of life. They form mats that look like thin, pale skin on rock. It's quiet, but it's not empty. It's simply an economy that runs on different fuel. Danger and discipline match quietly here. No jump scares, no doom talk, just the frank truth of physics and physiology. Depth squeezes gas in the tank faster. Breathing denser gas takes more effort. Color loss can trick the eye into thinking a light is brighter or dimmer than it is. Narcotic effects of depth can soften judgment. Overhead spaces require a clear exit plan and a line to find the way home when silt blooms across a mask. The rulebook that keeps divers safe is written in simple terms. Plan your gas like a budget. Keep a reserve. Stay within no decompression limits unless trained and equipped for more. Use 2 lights in the dark zones. Keep contact with the line and talk with hand signals that everyone understands. Teams matter. One leads, one follows, one watches the clock. Myths, like the idea that this is a terrifying place where people vanish, fade when the facts roll in. The real risks have names and solutions. Pros mitigate them. That's how the site has hosted thousands of calm, beautiful dives over the decades. Zoom out and the blue hole sits among a family of sinkholes and water-filled caverns that circle the tropics and subtropics like stars in a constellation. Mexico's Yucatan Peninsula holds cenotes linked to massive underground rivers, a stone lacework flooded when seas rose. The Bahamas host holes open to the sky and ones hidden inside islands with their own hydrogen sulfide layers and microbial tapestries. On Long Island in the Bahamas, one famous hole drops like a dark pupil surrounded by chalk-white shallows, hosting vertical walls and similar chemical boundaries. In another hemisphere, on the edge of the Red Sea, giant submarine sinkholes pock the sloping seabed. Each sibling looks similar from above, but the details differ like dialects. The depth of the cloud layer, the signature of sediments, the shape of side caverns, the species that can handle the chemistry. Compare enough of them, and patterns appear. Many form during the same sea level lows. Many carry stacked records of regional storms. Many host microbes that thrive on chemical energy in the absence of light. Study them together, and the planet's climate story comes into sharper focus. The blue hole is also a climate time machine, with its dial set to both past and future. In its stone and its mud, it remembers when seas sat lower, when coastlines were miles farther out, and when drought pinched forests on shore. It remembers storm pulses that came in bursts, then quieted. It logs the pace of sea level rise that drowned the cave, stepwise, with pauses and jumps. Those patterns matter now, as modern seas rise again, for different reasons. The hole's records show that coastlines respond unevenly, that flooding creeps inland in fits, that freshwater lenses over saltwater can thin and shift with changes in rain. The layers whisper that abrupt changes happen in Earth's system, and that resilience comes from knowing rhythms before they build. Quick fact: by matching the hole's storm layers with nearby coral breakage layers and with tree ring scars inland, researchers can map ancient hurricane tracks, not to scare anyone, but to calibrate risk where tourism and fishing depend on predictable seasons. Protection here means more than a buoy at the rim. The hole sits inside a larger wonder, a barrier reef system that arcs like a living wall along the coast. It's a UNESCO-recognized treasure, not because of one hole, but because of the whole chain: lagoon, mangroves, seagrass beds, patch reefs, barrier crest, and far atolls. Managing a place like this is part biology, part economics and part community. Zoning sets areas for no-take protection, for tourism, for fishing with limits. Enforcement means having boats, fuel, and trained rangers. Tourism economics are real. Trips put food on tables, pay school fees, and keep small marinas alive. That's why caps on visitor numbers, reef-safe sunscreen rules, mooring buoys to avoid anchor damage, and guide certifications aren't paperwork. They're how a reef keeps breathing under pressure. Collaboration with local operators and communities keeps the rulebook grounded. When people who depend on the water help shape the rules make sense at sea level, not just on a page. Future missions will press deeper into the portal with softer hands. Autonomous underwater vehicles can map without prop wash that stirs silt, or ROVs can fly into overhangs with fingertip control and record photogrammetry, thousands of overlapping photos stitched into a digital twin that students can explore in classrooms. LiDAR from drones above and sonar from vehicles below can fuse into a single model that captures the whole from rim to base with centimeter precision. Environmental DNA, or eDNA, is the quiet new superpower. A bottle of water holds traces of life from the last hours and days. Sequencing those traces reveals who swam by: fish, invertebrates, even traces of microbes that never sit still for a portrait. Long-term monitoring, tiny sensors on moorings tracking temperature, oxygen and currents can show how heat waves pass through the shaft, where the cloud layer sits season by season, and whether the life below shifts with subtle changes in chemistry. Open data means a kid in a faraway city can fly through the blue hole in a browser and see rock where the subs saw rock. That kind of access breeds new explorers. Visiting responsibly starts before anyone steps on a boat. Nest seasons often align with calmer seas and clearer water. Boat etiquette is basic. Follow crew instructions, stow gear so nothing blows overboard, wear a hat that won't fly into the sea, and keep sunscreen reef safe. Divers who come here should treat the site like a graduate course. Come with experience beyond the basics. Be honest about comfort with depth. Practice good buoyancy on easier dives nearby, and choose guides who brief clearly and don't rush. Emergency readiness isn't drama, it's preparation. Oxygen on board, radios working, a plan set before the first fin hits water. On the rim, snorkelers can savor the view without kicking coral. In the hole, divers can savor the geometry without touching the walls. The best souvenir is memory. The worst is a broken bit of limestone. Leave no trace is still the vibe, even when the trace would be invisible to most eyes. What if scenarios belong in the science notebook and on the surface, not in panic talk? Could a ledge destabilize? The rock here has stood through thousands of seasons and plenty of storms. Ledges that formed from old ceilings are thick and stubborn. If a section were to tumble, it would look like a fresh scar on the wall and a new pile on the floor. Recorded by the next mapping mission. Could an extreme storm dump a sudden heavy blanket of sediment into the shaft? Yes. And if it did, the base would show a fresh layer, coarser grains at the bottom of that layer. Finer grains, settling last, a signature easy to pick up later in a core. Short-term visibility would drop. Long-term, the layer would merge into the archive. Could changing ocean chemistry move the hydrogen sulfide cloud up or down? Subtle shifts already happen with seasons. Rainfall and exchanges with the lagoon. The cloud is a balancing act between sources of sulfur, oxygen mixing, and microbial activity. Monitoring can spot trends, and practical safeguards can adjust visitor practices if thresholds are crossed. Every scenario runs on mechanism and probability, not on nightmare. People have questions, and fast answers help. Is the water really that blue? Yes, because the hole is deep and the walls keep sand away. Blue light survives the journey best. So the shaft looks like a pure ink drop from above. How deep is it? Deep enough that the bottom is beyond recreational limits. For many visitors, the magic isn't the base. It's the walls, the ledges, and the sense of space. Is visibility always perfect? No. Currents, plankton blooms, and the cloud layer can change clarity. Are sharks a problem? Sharks are part of the reef. Most encounters are calm drive-bys. Should beginners dive it? Not the vertical shaft. Better to enjoy the rim and save the depth for later in a diver's journey. Why do cameras show colors differently than eyes? Cameras and lights bring back the reds and oranges that water absorbs. That's why video can look warmer than memory. What level of certification is ideal? Advanced training with deep experience and comfort with buoyancy is wise. Plus a guide who knows the site. Is there treasure at the bottom? The real treasure is time written in rock and mud. Anything else is just litter that doesn't belong. Does it connect to tunnels that run under the whole reef? There are side caverns here. But vast fantasy tunnels are stories, not maps. Can someone freedive the center? Freedivers visit the rim and nearby sites. But the depth here makes it a playground only for the elite. And the goal is always to return calmly. Do tides matter? Yes. Timing affects currents, boat handling, and sometimes visibility. Why does the rim thrive? Because sunlight, water flow, and habitat complexity meet there. While the shaft offers less food and fewer homes. How old are the stalactites? Old enough to remember dry air and the drumbeat of ancient drips. Labs put dates on them, but the headline is simple. They formed before the sea came back. Is the hydrogen sulfide layer dangerous to touch? It's not a ghost wall. Careful divers pass through in controlled conditions. But the lack of oxygen below it makes lingering a bad plan without specialized skills. Do whales visit? Offshore, yes. Inside the hole, very unlikely. Can storms change the shape of the rim? They can rearrange sand nearby and break coral on the crest. The limestone ring itself is a slow editor, not a quick change artist. Is the hole man-made? No, it's geology doing what geology does when caves drown and roofs fail. Why is it almost perfectly round? Because collapse mechanics average stresses into circles, and layered limestone gives in symmetrically when it can. Are there unexplored parts? There are corners and overhangs reserved for robots or the most trained humans. And every new map finds fresh subtlety. Will it last forever? Nothing does, but in human terms the hole will outlast several generations if people treat the reef kindly. The calm takeaway rises slowly with the narrator's breath. This place is gorgeous, but it's not a stunt, it's a teacher. On the way back up from the deeper ledges, the blue brightens. The rim climbs into view like a sunrise. A single school of blue chromis opens like a hand and closes again. Above, the surface shines like rippled glass. The grounded lesson is simple. The planet writes its diary in stone and salt, and anyone who listens can read it. Curiosity is the ticket. Responsibility is the price of admission. The descent through time continues, and the wall tells stories and patterns that even a child can follow. Smooth bands where water worked slowly, rougher patches where a collapse once rumbled, and tiny shelves where life tested the edge and either stayed or moved on. A person looking closely would notice how certain ledges feel like old stair steps, each one a memory of where the cave once had a floor, or a balcony before sea level rose and rewrote the room. It is not a fantasy portal, it is a stack of clues, and each clue is ordinary enough to feel trustworthy. Karst, the word for landscapes built from dissolving limestone, sounds technical, but behaves simply. Think of a sugar cube under a slow drip. The drip makes paths. The paths widen into runnels, and runnels can open into holes. Limestone is just a sturdier sugar cube made from ancient shells and skeletons, pressed by time. Rain picks up a hint of acid from the air and the soil, and that hint is enough to unlock calcium carbonate. Passages form along joints in the rock, like zipper lines that nature already started to tease open. Over thousands of rainy seasons, those joints become tubes, rooms, and vaults. Where rock roofs arch high and wide, stalactites grow from ceilings and stalagmites rise from floors, meeting sometimes to form columns. The presence of stalactites in this hole is the headline proof. They formed in air, drip by patient drip. Water cannot drip a stalactite underwater. The shapes are signatures of dry times. The ocean covered them later, and that order, air first, water later, is the key to the portal's identity. Now picture the planet's ice accounting. During glacial times, ice holds water hostage on land, and the sea pays the ransom by dropping. Coastlines extend. Continental shelves breathe air. Caves that once leaked quietly into the sea now stand high and dry. Then the ice lets go. Meltwater returns to the ocean, and sea level rises. It does not move like a straight elevator. It steps, pauses, sometimes surges. As the sea climbs back up the shelf, it floods caves from the lowest rooms upward. Air escapes, buoyant and eager. Water takes its place, denser and slow. A cave roof that held firm in air can fail in water, because buoyancy, tides, and slow dissolution rearrange pressure on thin points. When that failure happens close to the surface of the flooded cave, the collapse opens a mouth to the sky, a sinkhole. Over time, chisel by chisel of chemistry, the rim settles into a circle because forces spread evenly along a ring. The result is the view from the airplane window that everyone recognizes, a perfect dark disk inside a pale azure lagoon. Inside the shaft, that pale cloud becomes the scene's soft villain that isn't actually villainous. Hydrogen sulfide forms when bacteria in low oxygen environments feed on sulfur compounds and recycle them in a food chain that owes nothing to sunlight. In the world above, plants and algae use light to power life. In the world below the cloud, chemistry is the engine. If a diver were to pass through the layer, the smell would not travel underwater to a mask, but the eyes would feel the fog's grainy personality. Light scatters, shadows flatten, and any sense of the open ocean dissolves into a room with no corners. The oxygen level drops beneath the layer. Fish that wander too long in the wrong neighborhood often turn back quickly. Microbes, however, thrive, weaving mats and films on rock that look like soft paint. That boundary is more than a cool effect. It is a line between economies, photosynthesis above, chemosynthesis below. On the topic of economies, the rim reef operates like a day market in a seaside town, busy and cooperative. Corals lay down limestone skeletons that look delicate but hold real strength. In their tissues live microscopic algae that trade sugar for shelter. That trade makes the vibrant colors that tourists love to see and that cameras love to exaggerate. Parrotfish, with beaks built to nip dead coral and scrape algae, chew rubble into sand, so fine it feels like flour, between the toes on nearby beaches. Sponges filter liters upon liters of water each hour, clearing out particles and feeding quietly. Cleaner fish establish stations where bigger fish and even sharks hover for a tune-up. Everything survives by finding a niche and respecting a rhythm set by sunlight and currents. Heat waves stress the whole market. Corals can lose their algae partners, turning pale, the well-known bleaching effect. If temperatures fall and stress eases quickly, many corals welcome the algae back and color returns. If stress lingers or repeats too often, some corals fail and the architecture erodes. The rim tells that story in small scars and big recovery. Turn back to the rock diary. A stalactite is a pencil that wrote its paragraph in vertical script, one thin layer at a time. Each layer made from water that fell from the cave roof, carrying dissolved minerals and a whisper of the weather outside. When rainfall is steady and soils are moist, drip rates increase, layers grow a little faster, and the chemistry leans toward signals of wetness. During dry stretches, drips slow, layers thin, and isotopic ratios shift. Those isotopes, most notably oxygen-18 to oxygen-16, change in ways that reflect temperature and rainfall. Laboratories remove powder from rings along the growth axis and read those isotopes with instruments that can tell differences smaller than human intuition would think possible. In parallel, uranium naturally present in trace amounts decays to thorium at a known rate. Measuring that ratio locks down the age of the layer with an uncertainty range that looks like plus or minus a small number of years or decades. That range matters It is how science stays honest about what it knows and what it might be off by a hair on. When the ages line up between stalactites in this hole and stalagmites in caves on the mainland, confidence rises. When they also line up with coral growth bands in nearby reefs and with faraway ice cores that tell of polar snowfall, the story becomes a global chorus. Sediment cores bring a different voice to the choir. A core tube that sinks into the soft bottom and comes up again is a timeline in a plastic sleeve. The lowest portion is oldest. The topmost is youngest. Within are tiny worlds, bits of broken shell, grains of quartz from river mouths, volcanic dust from distant eruptions, layers of organic material from blooms that came and went. After a major storm, a distinct sandier layer may appear, coarser and better sorted, resting on finer mud like a miniature frost line. In years of calm, the layers look more uniform and thin. Pollen grains can even drift this far out. A microscope reveals what plants dominated the nearest shore during different centuries. Put all these together and a climate tape emerges, sometimes smooth, sometimes jumpy, always more detailed than a general history textbook. Humans changed how this place is seen, and each era left a different kind of footprint. Before motorboats and snorkel masks, the reef was navigated by people who knew the color of water and the way a line of white on the horizon marks a barrier. Canoes and small sailcraft learned to read the shallows, and knowledge passed by demonstration and story. In indigenous cosmologies of this region, caves and cenotes, water-filled sinkholes on land, were respected as connections between surface and underworld, the living and the ancestors. A marine blue hole fits that cultural map, a place to approach with care, not as a dare but as a threshold. Then came lighthouses and charts. The shallow banks and cays received names, soundings marked depths, and circles marked hazards and landmarks. A dark circular patch inside a lagoon was a note any navigator remembered. Modern exploration took recognizable shape in the mid-20th century, when underwater cameras, scuba gear, and dedicated research vessels met curiosity. A charismatic team with a famous red cap turned this hole into a star, with a broadcast that made living rooms around the world feel the hush of the descent. That mission installed more than a narrative. It set a tone for safe, purposeful diving, trained people, clear plans, respect for limits. Through the 1980s and 1990s, technical diving techniques matured, allowing trained teams to go deeper with mixed gases and to enter overheads with reels, redundant lights, and strict protocols. They found fallen stalactite fragments on ledges, sketched the rooms that open off the main shaft, and reported visibility changes near the cloud. Their logs read like careful field notes: depth, time, team position, gas mix, line markers, light signals. In the late 2010s, submersible pilots returned with sonar arrays and high-resolution cameras. From the surface, the boats looked like quiet film sets. Below, the subs were methodical dragonflies, hovering at set altitudes and tracing planned transects back and forth like mowing a lawn. Sonar beams fanned out and returned with precise delays that a computer turned into a point cloud. That cloud became a digital sculpture. Walls, benches, the base, and the small talus piles where rock had fallen. Pilots described the moment of entry into the cloud layer as eerie but oddly gentle, like driving into milk that forgets to swirl, one said. When the data published, the public saw something the naked eye could not: the exact shape of the hole, not as a postcard circle but as a complex textured cylinder, signed by geology's slow handwriting. Tourism matured alongside technology. Early day boats carried small groups accompanied by guides who knew where a novice's eyes would widen and where a novice's buoyancy would wobble. Over time, operators built routines that feel almost ceremonial. Pre-dive safety checks lined up row by row, hand signals rehearsed, a reminder to look but not touch. The quiet final nod before entry. Incidents produced learning. A diver who reached a depth faster than planned and felt the early tug of narcosis came back up safely with a guide and later described the sensation as a soft focus on decisions. That story echoed in future briefings about depth awareness and buddy contact. Another team that strayed into a narrow overhead without a guideline learned quickly how a silt-out turns a room into a perfect replica of night. Their debrief became a cautionary tale that shifted operator policy. No overhead penetration on tourist dives, period. Only training lines for those enrolled in technical courses. Each adjustment lowered risk without squeezing the wonder out of the experience. The practical rulebook that keeps this site calm could fit on a waterproof card. Plan the dive and dive the plan. No surprises. Use the rule of thirds for gas in overheads. 1/3 in, 1/3 out. 1/3 reserved for the unexpected. In open water without overheads, keep a conservative reserve anyway. Watch depth. The numbers are not abstract. In a place where the wall invites the eye downward, keep neutrally buoyant and trim, so a fin does not kick the wall and a hand does not graze a sponge. Carry 2 lights if visiting dimmer zones. If one fails, the other keeps the path lit. Follow the guide's line in places where orientation can deceive. Know that nitrogen narcosis can soften judgment at depth. Plan maximum depth accordingly, and build in margins that match certification, recent experience, and conditions. These are not rules for thrill-proof humans. They are habits that make a beautiful place stay beautiful. Back to the science toolbox. Each tool answers a different kind of question. Multi-beam sonar, maps, shape side scan. Sonar sketches texture by sending sound sideways and reading shadows behind bumps and ledges. Photogrammetry uses thousands of overlapping photos to build a texture-rich 3D model. It's measure with pictures. Core sampling collects time in a tube. Micro-CT scanning can image those cores without slicing them, preserving structure for visible inspection and future studies. Geochemistry reads those slices. Uranium-thorium dating pins ages. Carbon dating applies where organic matter is preserved and where the time window fits. Stable isotope analysis acts like a thermometer and a rain gauge baked into stone. Trace element ratios hint at dust sources or water-rock interactions. When a lab reads a stalactite from this hole and finds a pause in growth, that pause may correspond to a time when sea level reached the cave ceiling. Growth in air stops because the cave is drowned. That signal gets matched to global sea level curves and to coral reef terraces along the coast that sit at fixed elevations relative to today's tide. Cross-checks matter. They keep one line of evidence from carrying the entire narrative alone. Ecosystems paired with geology make the whole more than a shape. On the rim, certain corals act like hardy foundation builders. Branching forms in some zones. Massive boulder corals in others. Schools of grunts and snappers gather over the spurs and grooves. Tarpons sometimes cruise the edge, their reflective scales flashing like old coins. A hawksbill turtle may dip a flipper into the shaft's shade and then return to the shallows where sponges taste better. Barracuda hang motionless, interested in everything and committed to nothing. Overhead, frigate birds and terns patrol the air like casual supervisors. On the wall inside the hole, long black wire corals extend like antennae, and orange or purple sponges cling to spots with good flow. Where the cloud layer sits, life thins and changes. The sense of city fades to outpost. Microbial life picks up the story, and to appreciate it is to accept that energy comes in more flavors than light. Resilience and stress play out here like a slow chess match. The rim faces warm spells that can push temperatures beyond a coral's comfort. It also faces human pressures, sunscreen chemicals that are harsh for tiny larvae, careless anchors that scar, too many flippers over a patch of branching coral that breaks like dry twigs. Every coastal system that hosts visitors runs that risk. Countermeasures exist and are simple. Mooring buoys so anchors stay off the reef, reef-safe sunscreens, briefings that teach no touch, no stand, no chase, caps on daily visitor numbers, and most important, community buy-in, so operators feel pride in protecting the site that feeds families. Recovery is real when pressure eases. After a heat wave ends, pockets of reef that held on can seed damaged patches with new larvae. If herbivorous fish are abundant, algae won't claim the empty real estate too quickly. and corals get a fighting chance to return. The rim is a lesson in how small choices scale up. The family tree of blue holes and cenotes opens a fun travelogue for the mind. Cenotes on the Yucatan are windows into a vast underworld of rivers that travel horizontally through limestone before finding the sea. Some are open pools with vertical walls. Others sit inside collapsed caverns with stalactites still hanging like old chandeliers. Their waters can layer too, with fresh rainwater floating over salt water that intrudes from the coast, creating a holocline so clear it looks like glass and so bright it bends images. In the Bahamas, another famous blue hole drops near a beach where freedivers gather to test skills in a site that blends accessibility with depth. Its sides feel close compared to this Belizean shaft, and its own hydrogen sulfide layer has a personality that freedivers avoid by staying well above it. In the Red Sea, a blue hole with a notorious reputation hosted tragedies from overconfidence and poor planning. Its geology is different. An arch leads to open sea at depth, tempting divers beyond recreational limits. That site's story, often told with too much hype, supports one grounded message: different holes have different rules, and respect for those differences is non-negotiable. The Belizean hole, framed by an atoll and absorbed into a protected reef system, tells a calmer tale: geology first, chemistry second, tourist rite of passage third, when visited with brains engaged. A climate lens makes the portal feel practical, not just poetic. The stone says plainly that sea level can change enough to turn airy halls into submerged chambers. The sediments say storms come in clusters, then leave quiet gaps. When those records are placed beside modern projections, a sobering but not hopeless picture appears. Coasts will need flexible thinking. Mangroves are allies worth planting and defending, and reefs are both sentinels and shields. Reefs break wave energy. Healthy ones guard shorelines during storms, lowering the height of water that reaches beaches and seawalls. Mangroves and seagrass beds inside lagoons trap sediment and store carbon while giving juvenile fish safe nursery. The blue hole's position inside a larger reef lagoon mangrove mosaic underscores a simple coastal truth: protection works when the whole system gets attention, not only the postcard center. Management in this region has marched through phases: recognition, designation, enforcement, adaptation. Recognition arrived as scientists documented biodiversity and geomorphology. Designation came with national protections and international acknowledgement, placing the wider barrier reef system on lists that matter to policymakers. Enforcement, the hardest part, demanded boats, salaries, fuel, training, and legal teeth. It also asked for patience. Building a culture of compliance among locals and visitors takes repetition and fairness. Adaptation is where the most interesting work happens now. Creating zones that move with ecological reality, adjusting quotas and seasons for fisheries, setting tourism caps that match carrying capacity, and using permits and fees to fund ranger patrols, mooring maintenance, and monitoring. Community voices sit within these discussions: fishers who know seasonal patterns better than any satellite, guides who see changes week to week, and families who need both income and a reef their children can enjoy. A technology is not a show-off here. It is a quiet servant. OUVs can fly pre-programmed patterns, mapping without bubbles. ROVs can enter side caverns no human should, lighting softly and keeping thrusters away from silt. Drones can scan the rim at low tide with LiDAR, capturing microtopography of the reef crest and the coral heads that peek at the surface. Combining those datasets, LiDAR above, sonar below, images everywhere, produces a digital twin that educators can share in classrooms and that managers can use to measure change. A rock that shifts between surveys becomes a conversation starter. Was it a storm push, an internal collapse, or just the angle of light? eDNA sampling adds a superpower. A liter bottle pulled from different depths contains fragments of genetic material shed by passing creatures. Sequencing reveals a roster of species without catching or tagging anything. Over a year, patterns emerge: seasonal visitors, resident fish, and microbial communities that reconfigure with heat pulses or fresh influxes from the lagoon. Long-term sensors log temperature, oxygen, and currents every hour of every day, making heat waves visible as they slide through the shaft and showing how the hydrogen sulfide cloud rises or falls across months. Public dashboards that share those graphs in near real time turn curiosity into connection. A classroom far away can watch the reef breathe. Visiting responsibly begins with honesty about skill and comfort. A diver who has only just earned certification can still enjoy the day. The rim is wide, the shallows are lovely, and the view across the circle from a safe depth is cinematic. More advanced divers who plan to descend into the shaft should have recent experience with deep profiles, a sense of how nitrogen narcosis feels in their own bodies, and the judgment to call a dive early if anything looks off. A good guide will say out loud that turning back is noble, not embarrassing. On deck, small habits: clipping gear so nothing falls overboard, keeping plastic bags away from the rail, using refillable water bottles, save the sea from tiny injuries. Sunscreen formulated without harsh chemicals keeps coral larvae from suffering invisible stress. Fin tips kept high near the reef prevent accidental breaks. The best photos are taken with lights that are close to the subject but with hands that are far from the subject. No picture is worth a snapped sponge. Speculation enjoys boundaries. Could the hydrogen sulfide layer climb higher in the column over decades if circulation patterns in the lagoon shift? It could, especially if organic matter entering the system grows while oxygen mixing decreases. Would that change the visitor experience? It might move the cloud into ranges where recreational divers normally travel, turning today's dim zone into tomorrow's caution zone. Sensors would see the trend long before it caused surprises, and managers could adjust dive profiles accordingly. Could an earthquake crack the rim? Small tremors often pass with no visible change. Larger events could create fresh fractures or slumps, leaving new talus at the base and a slightly altered outline. Post-event mapping would log the change, and adaptive moorings could be moved to respect new safe zones. Could extreme rainfall on the mainland push more fresh water and nutrients into the lagoon, altering haloclines seasonally? Yes. The boundary between fresh and salt can wobble, bringing layers into and out of sight and changing where certain organisms prefer to sit. Each scenario is less about fear and more about situational awareness. Back to the clock in the rock, because time deserves another pass from a different angle. Imagine a series of stalactites cut cleanly to reveal their cores, each ring read like a vinyl record by a laser stylus. The readings produce wiggly lines, graphs with peaks and dips that align or offset among multiple samples. When 3 different stalactites in the hole show a pause at roughly the same depth and that pause dates to a time centered around a known sea level jump, the case strengthens that the cave drowned to that ceiling. If a sediment core shows coarser layers that cluster in periods when coral growth bands also show stress, a stormier interval is likely. The blue hole therefore becomes both a thermometer and a barometer, though not with numbers someone can read at a glance. It is a slow, careful kind of instrumentation that requires patience and cross-checking. The reward is a picture of the last tens of thousands of years that helps frame the next few centuries. A brief return to human stories keeps the narrative human-sized. A veteran captain, who has run trips for decades, often tells guests before the first dive, "The site doesn't care who anyone is. It will be exactly itself today." People have the easy job: match its calm. A local guide who grew up on the coast sometimes steps to the bow when the rim comes into view, and pauses, letting newcomers feel the scale before a single instruction is given. A scientist who helped process speleothem samples once described the delight of looking at a sample under a microscope and seeing a mineral layer that corresponded to a known drought period. "It's like shaking hands with a year that nobody here remembers," they said. These quotes share a theme that makes this place special. Nobody performs here, everyone attends. If a child asked what the hole is, a gentle answer would suffice. It is a giant sinkhole in the sea, made when a cave fell in after the Ice Age, with layers of water that stack like flavors in a dessert, and rocks that grew when the cave was dry. If an older adult asked what it teaches, the answer would add a line. It teaches that Earth changes slowly most of the time and quickly, some of the time, and that people can learn from the slow parts to prepare for the quick ones. Neither answer needs big words, because the place itself is the big idea. Navigation and seamanship deserve a small nod here, because they crafted the human dance around this hole. The atoll's channels are narrow in places. The trades can push chop across the lagoon, and skippers learn to read light on water, the way readers scan lines on a page. Mooring lines placed thoughtfully keep anchors off coral heads. Briefings before snorkeling remind guests that even a slow fin kick can break a brittle star. Divers rehearse the plan on a deck that smells faintly of salt and neoprene. Then enter without rush. After the dive, tea or water tastes better than it should, and a lazy, content silence fills the deck. That rhythm is part of the site's identity as much as the geology. Approach, learn, enter, leave better than it was found. A small gallery of visual illusions rounds out the descriptive toolkit. Underwater, everything looks a little closer and a little larger, because water bends light more than air does. A ledge that seems within a few strokes might be farther, and the wall's curve may hide more distance than a quick glance suggests. Colors shift. Reds die first. Blues win by being the last color left standing. A camera with a white light can make a gray sponge glow warm and alive. The human eye can only see that color pop if a light is present. That is why video footage can look richer than a memory. None of this is deception. It is physics painting with a limited palette, and knowing the palette helps a visitor understand what is seen and what is missing. There is room for humor even in a science-forward story, as long as it stays gentle. Guides sometimes joke that parrotfish are beach manufacturers, and it is literally true. Much of the sand on some tropical beaches is digested coral. Another quick fact: a single big parrotfish can process hundreds of pounds of coral in a year and produce a surprising amount of sand. A child hearing that usually laughs, then stares at the shoreline with a new kind of respect. These small hooks pull people into caring without lectures. Education programs tied to sites like this lean on that kind of hook. A marine station might host a day where local students take water samples at different depths in a protected lagoon, measure temperature and salinity, and then compare those with a virtual dive into the blue hole's water column data. Students see a halocline on a graph, and then see it again in a narrated video. A concept becomes a memory. Citizen science invites visiting divers to note fish species on a slate or to take a photo of a specific coral head a few times a year. From the same angle, those repeat images build a time-lapse that reveals growth or stress. In this way, the site turns from tourist magnet into classroom, and classrooms magnify stewardship. Economics enter the picture, but the story resists cynicism. Sustainable tourism requires prices that pay crews well, maintain boats, fund moorings, and contribute to enforcement. It benefits from caps on daily numbers, so guides can give attention and reefs can rest. Operators who treat safety briefings as a shared ritual and environmental briefings as an honor code tend to attract guests who return. Local businesses, small restaurants, gear shops, mechanics, and the workers who staff them ride on the success of a reef that remains attractive. The point is not to turn a hole into an industry. The point is to let a community thrive around a wonder without wearing it out. For those who will never visit, the story still offers a way in. The digital twin of the hole, hosted online, takes anyone down the shaft with a trackpad and a curious eye. A narrated fly-through can hover under the rim and then dip into the cloud until contrast vanishes, then back up into clearer water where the ledges show again. A pop-up can show a stalactite and explain in 10 words that it grew in air and therefore remembers a time before the sea returned. A child could play that twice and then describe it at dinner. That kind of access seeds future care. Another return to comparisons across the family tree helps lock in understanding. The holes in the Bahamas often show clearer layering between fresh and salt, because large island aquifers feed fresh water out through the rock. This produces haloclines that form shimmering mirrors. Cenotes sometimes connect to each other through submerged tunnels, creating kilometers of navigable cave for trained cave divers. No such miles-long connections define this Belizean shaft, which is more of a lonely vertical than a connected subway. In the Red Sea, the Blue Hole's arch tempts divers with a promise of an easy swim through. The price is serious depth, and the site's tragedy count rose before strict protocols took hold. The Belizean hole, by contrast, sits calm because most visits mind the vertical and because overhead rules are firm. Each site's personality is shaped by geology and by human behavior around that geology. In a world that often pushes speed, this hole celebrates slowness. Stalactites recorded centuries in skinny layers. Sediments recorded storms in thin stripes. Management changes take seasons to show results. A coral head grows in centimeters per year at best. A child grows in centimeters per year too, and may return as an adult to see the same coral as a neighbor, still there, a little larger, familiar in outline. This is how stewardship becomes personal. Repeat visits, repeat looks, small acts repeated until they become culture. Cameras deserve a small, friendly, myth-busting moment. Videos online sometimes show the hole as a bottomless pit, an abyss that swallows light without end. It is deep, yes, but not infinite. Depth numbers matter. Guides state them clearly, and divers track them on gauges that beep if limits approach. The point of a day here is not heroism, it is perspective. Standing on a boat rail and seeing that perfect circle, then floating over the edge and feeling the gentle drop of light and sound, teaches scale better than any measurement. The rim is the horizon of a small world, and the wall is the story's text. One more turn through safety culture keeps the narrative grounded. Team roles are not mere jobs. They are a communication web. A lead guide watches the group and the clock. An assistant watches the quiet details. Who hovers too close to the wall? Who drifts a little under the group? Whose fin straps need a friendly tug? Divers check each other's valves and clips. On descent, the group stays together so nobody rides a false sense of comfort from seeing bubbles somewhere below. On ascent, the group returns to the rim slowly, letting gases leave bodies in a calm, predictable way. A safety stop near the shallow lip becomes a scenic pause rather than a chore. On the surface, roll calls happen before boats move. These habits are not dramatic. They are boring on purpose, and boring is what safety looks like from the outside. Finally, a gentle bridge leads forward to the eventual wrap without closing anything yet. The story will climb later, retracing the blue gradient back to the sun, and it will end with a quiet thought. For now, the camera of the mind lingers on the ledge where an ancient stalactite hangs, heavy and sure, pointing down with the patience of geology. The hole has kept time longer than people have watched it, and it will keep time long after today's boats have turned back toward the islands. The best way to honor a clock like that is simple. Look closely, learn thoroughly, and leave lightly. The day breathes across the atoll as if nothing unusual sits in its center. Trade winds comb the palms on far quays, small ripples ride the lagoon, and the rim holds its line the way good stone does, without fuss. The hole's reputation tends to outrun its reality in conversations far from the sea, yet the reality is richer, a place that asks for quiet attention, not adrenaline. The narrator's voice can set that mood, calm, clear, and unhurried, because the hole itself is none of the things an urban legend would demand. It is patient, and patience is contagious. The rock still deserves a closer look, because its small details carry big meaning. Along the inner wall, faint scallops show where water once moved faster along narrow paths. These scallops are bite marks left by centuries of flow, and they point the direction of the old current, like arrows painted by geology. In alcoves, sponges settle into patterns that look random until the eye notices they favor tiny shoulders where food arrives more often. On broader ledges, the occasional fallen stalactite lies like a fossilized husk, heavy as a memory. Some of these fragments snapped long before the modern sea arrived. Others fell under the slow shifts of buoyancy and stress after the flood. Each one confirms the cave's age in air, because stalactites by definition wrote their stories one dry drip at a time. Anyone who has stood in a limestone cave on land can translate the scene. On land, the ceiling drips. A lamp shines, and the ceiling shows thousands of stone icicles in different stages of growth. A guide points to a column where stalactite and stalagmite met halfway. Underground rivers whisper in side passages, and walls carry patter that look like frozen waves. Now transport that same room underwater and let the ceiling fall in. The floor becomes a bowl. The new mouth opens upward to the sun. The rock keeps its textures, and the drips stop because there is no longer a difference between room and river. Water fills both. That's the blue hole's core story, made simple enough for a child and complete enough for an expert to nod along. Quick fact worth pocketing for later. The rate at which stalactites grow depends on drip rate, temperature, and the concentration of dissolved minerals. Growth can be fast by geologic standards, millimeters per year, or extremely slow. That variability is what makes them sensitive climate recorders. When the ocean returned and drowned the cave, growth stopped. The cut ends and the mineral stains where freshwater once ran are clean lines in time. Dating methods reach in and put numbers on those lines, turning a picture into a timeline. Eyes shift from rock to water again, because the water column is a character in its own right. At the rim, the light is generous. Sunbeams stripe the wall and throw moving shadows that feel like the play of leaves on a sidewalk in summer. Fish animate those stripes with their bodies, each a small piece in a large choreography. Deeper sunlight stretches thin. The beams elongate and lose sharp edges. This soft fade changes how sounds feel too. At the surface, water licks the hull. Divers talking on a deck sound like softly clinking metal. Below, bubbles become the metronome, and a heartbeat feels louder than it does in air. Even though it is not drama. It is merely the brain recalibrating to a world where familiar cues have a different mix. The hydrogen sulfide cloud layer can be imagined as a fog that forgot it was supposed to move with the morning and instead chose to live here. It separates two agreements with life. Above it, oxygen and light make deals together. Below, oxygen thins and chemistry takes the lead. Microbes down there eat in a way that sidesteps the sun. They hustle at gradients where the energy lies, making a living on what looks like leftovers to a human. These communities do not ask for applause. They work quietly and mark out zones on the rock that reappear, survey after survey, like the lines of a tide that never reaches the beach. For most visitors, the rim is the classroom, and the shaft is the lecture hall's high ceiling. Viewed from a safe aisle, the rim's corals tell the story of partnership that powers reefs, coral animals hosting tiny algae in their tissues, trading food for lodging in a balanced economy. That partnership explains both strength and weakness. When heat overstays its welcome, corals push the algae out. That eviction makes them pale, bleached, and vulnerable. If temperatures drop back into comfort soon enough, corals let the algae back, and the city's colors return. This is why managers track temperature so closely. A reef that can rest and recover between heat waves stands a chance. One that never gets a break exhausts itself. The hole's rim, connected to the vast barrier reef, benefits from that regional ebb and flow, from currents that bring relief, and from policies that keep local stress low. The human timeline runs alongside. Before the world learned the hole's name, fishers and guides knew the atoll's moods. There is a wisdom in pacing that older captains still teach. Watch the squall line and know whether it means a simple rinse or a short rough patch. Time the lagoon crossing to match the tide. Listen to the sound of the reef crest in a headwind, how it changes pitch with surge. That seamanship is part of the site's invisible safety net. as important as a dive computer or a sonar unit. When larger expeditions arrived, the ones with logos and cranes, those captains and crews were often the quiet backbone of success. Later, when tourist boats began running, many of the same mariners shifted from nets and traps to tanks and briefings, bringing a culture of care with them. A few reported episodes over the decades became inflection points for best practices. A diver who underestimated gas consumption at depth learned a lesson the team then folded into briefings. Depth hunger is real, and a pretty wall can tempt even disciplined minds to drift downward without noticing. A guide, years ago, spotted that drift early and called the team upward before the numbers got tight. The post-dive talk that day became a story told 100 times since, not as a scare tactic but as a positive illustration of how attention and conservative planning feel in action. In another case, an anchor dropped by an unlicensed boat in the wrong patch left a scar that lasted a season. Photographs of that gouge made the rounds and helped lock in the rule that mooring buoys are the only acceptable way to stay put near the rim. People often need to see harm to believe it. Once they do, they generally prefer not to repeat it. Science teams added their threads, and those threads became strong fabric when woven across years. A 3D sonar model from one mission met a refined photogrammetric model from another, and the two together revealed ledges in sharper relief than either alone. A sediment core pulled one year was read for storm signatures. A second core pulled later from a slightly different spot found the same big storm pulses in the same order, confirming that the record wasn't a lucky accident of location. A set of stalactite fragments, sampled carefully for uranium-thorium dating, gave overlapping ages for a key pause in growth, and those ages matched known sea level steps from global records. That kind of triangulation is how a site goes from we think to we can show. The comparison set beyond Belize adds confidence and nuance. In the Bahamas, certain holes hold a laminated record of their own in fine layers laid down over millennia, sometimes interrupted by thick storm beds that tell of truly powerful hurricanes. In Yucatan's cenotes, stalagmites in dry caves close to the surface hold a rainfall record that can be matched against the blue hole's marine signals. The two together draw a sharper picture of how coastal systems responded to changing water availability over centuries. In the Red Sea, the chemistry and depth differ, but the principles rhyme: boundary layers, microbial life that treats chemicals like sunlight, and walls that tell of caves turned inside out. Set side by side, these sites stop being isolated wonders and become chapters in a book that spans oceans. Even with all this science, the ask for visitors remains simple: bring curiosity and leave assumptions on shore. Choose a guide who communicates clearly at the dock and under the surface. Agree on maximum depth and stick to it. If anything feels off, breathing rate, air clearing, buoyancy, call it early and enjoy the rim. The hole is not a test, it is an experience. The best dives here are the ones that end with everyone climbing the ladder content and a little quieter than usual. The question of seasons comes up, and it deserves a straightforward answer. Calmer seas often arrive during predictable stretches. But weather is weather. Smart operators hold flexibility. Water clarity shifts with plankton blooms and wind. Some days the circle looks like a lens. Some days it looks like ink stirred with a straw. None of that subtracts from the site's core. It simply adds personality. A traveler choosing dates would do well to listen to local advice rather than chase a single best month posted in a forum far away. Locals know the rhythm and share it when asked respectfully. Inside the box of what-ifs, consider the future of the hydrogen sulfide layer under modest climate shifts. If lagoon productivity increases, more organic matter may drift into the shaft. Microbes feasting on that rain would consume more oxygen, perhaps thickening the layer or nudging it upward. Managers could respond by adjusting recommended dive profiles, emphasizing the beauty of the upper ledges and the rim even more, and by increasing the cadence of water column monitoring to watch trends in real time. If warming events become more frequent, the rim's corals will need longer rests between heat waves to avoid chronic stress. That makes local protections, limits on physical damage, water quality controls and fish population health all the more important. The hole cannot change the global thermostat. It can benefit from local shade, so to speak, provided by smart policy. Education threads through all of this, like a current that never quite sleeps. A boat briefing is education. A sign at a dock explaining reef-safe sunscreen is education. A classroom in a city streaming a live Q&A with a ranger at the atoll is education. When a child hears that a parrotfish makes sand and then sees a video of a parrotfish biting coral, the world clicks into a new shape. When an older adult hears that a stalactite recorded a drought centuries ago and that scientists can read that drought's fingerprint today, the span between past and present shrinks, and the pace of change feels comprehensible. A site like the Blue Hole is therefore not only a destination, it is a teacher that travels through stories and screens. Myth-busting can remain generous rather than smug. If someone says the hole is bottomless, a gentle correction, it is deep, but it has a floor that science has mapped, keeps wonder intact, while replacing fancy with fact. If a video shows someone streaking down the center without a line or a plan, a patient explanation that is a choice for experts with support teams, not a template for a vacation dive, protects newcomers without shaming heroes. A well-run site grows a culture where good choices are seen as cool and where bragging rights attach to courtesy and control rather than to flirting with limits. The rim to abyss contrast can also be used to talk about energy. Above, sunlight powers plants that power animals. Below the cloud, chemical reactions power microbes that support a small specialized food web. This is a neat way to introduce the idea that life does not require sunlight everywhere. If a child hears that and later reads about life under ice in a polar ocean or around hydrothermal vents, the connection will be easy. The Blue Hole becomes a bridge to bigger ideas beyond tourism, a stepping stone in understanding how life finds a way in strange places. Turning again to the clock in the rock, one can imagine how researchers construct a clear timeline from fragments without taking the hole apart. They work small, sampling where broken pieces already lie, preferring fallen stalactites to intact ones. They do not harvest trophies, they read diaries. A polished slice the width of a finger can hold centuries. The lab places dots along a line on that slice and takes powder from each dot, then extracts isotopic signatures that carry the weather print of the year when that calcite settled from a drop. Very often, the curves these dots create, the wiggles and dips, match patterns seen in entirely different records. A cave on the mainland, a sediment core from a nearby lagoon, a coral head's growth bands. That alignment is not coincidence. It is a chorus. This is why science at its best sounds like harmony. One instrument is interesting, many together are persuasive. The role of enforcement in keeping this chorus healthy deserves a human face. Rangers patrol in small boats, recognizable as much by their quiet professionalism as by any insignia. They check permits, advise on moorings, and when necessary explain why a practice has to stop. Most conversations are friendly. Once in a while they are firm. The goal is not to catch people, it is to guide behavior. Revenue from permits and fees circulates back into fuel, salaries, and mooring maintenance. That loop, when explained openly, wins support. Local operators know that a reef protected today is tomorrow's calendar booked. Rangers know that operators who make a living from a reef are the reef's watchful neighbors. Both sides need the other. Stories from rescue drills and real emergencies carry useful lessons without adding drama. A simulated diver recall at the rim involved whistles, a delayed surface marker buoy, and a methodical track along the wall. Everyone surfaced safe and bemused at how efficiently practice removed jitters. In a real event years ago, a diver surfaced far from the boat after misjudging a current. The captain kept eyes on the person and took a slow arc to pick them up, avoiding prop wash near the reef crest. The rescue became a calm anecdote and a reminder that line of sight and slow boats solve most problems. The site's reputation improved, not because nothing ever happened, but because when something did, people handled it well. Technology keeps adding quiet tools to that competence. A small beacon clipped to a diver's BCD can send a location signal to a receiver on the boat if the diver surfaces downwind. A handheld sonar can help a guide confirm position near the planned ledge without over-relying on memory and lower visibility. A drone from the boat can fly a quick circle at altitude if a surface search is needed, giving eyes beyond the rail. None of this replaces skill, it complements it. The culture remains skill first, tech second. The economic ripples touch towns in ways that are tangible. A mechanic who services outboard engines has steady work when boats run. And the boats run when reefs draw visitors. A small cafe near the marina sells breakfast rolls and coffee to crews leaving before dawn. It stays open because crews need it. A kid who helps a parent rinse gear learns early that salt eats metal if left alone. Later, that kid might study marine biology or boat building because the sea was always more than a horizon. These ripples are why protection is not an abstract moral choice here. It is a daily practical one. A reef that thrives feeds more than fish. It feeds a culture. There is also room for art and story. Painters have captured the circle from above, using a single deep blue to pull the eye, a simple compositional trick that works because the scene itself is simple. Writers have borrowed the whole as a metaphor for memory, for time, for secrets that are not sinister but simply deep. A musician visiting the Keys once said the rim looked like a vinyl records label, with the sea as the spinning disc. These harmless appropriations help the site live in minds beyond science and tourism. They make the whole part of a wider human story. One can imagine, too, the next generation of submersibles revisiting the shaft. Smaller, quieter craft could slip into overhangs, with LEDs set low to avoid washing the scene in harsh light. High dynamic range cameras would capture the subtle textures of the wall where today's cameras flatten them. Gentle suction samplers, think of them as underwater vacuums with a soft touch, could collect a smear of microbial mat from a precise spot, and then replace a clear marker so future teams sample nearby rather than on top of the same patch. Over years, a mosaic of samples would build a better understanding of how these communities change, or how steady they remain across seasons and heat waves. OUVs could carry chemical sensors that measure microgradients at the edge of the hydrogen sulfide layer, mapping its shape like a contour line on a hiking map. The goal isn't to conquer a place, it is to listen to it with better ears. Visiting remains, as ever, a privilege. A day on the boat begins with names and ends with thanks. In between, there is a curve drawn on the sea by a hull, a circle drawn on the sea by geology, and a curve traced in memory by a human who chose to look closely. The etiquette is old-fashioned and always in style. Listen, help, tidy up after yourself, and keep hands to yourself underwater. The payoff is as modern as any high-tech thrill. Perspective. What the blue hole reveals about the future is not a prophecy, but a set of constraints and opportunities. Sea level will rise this century. The rates and projections vary, but the direction does not. Coasts near this reef will adapt better if mangroves are healthy, if seagrasses are intact, and if reefs keep their height and roughness. The hole's rock remembered a time when the sea was lower. Now it will witness a time when the sea grows higher. Its ledges will not move up to help anyone. People will need to move their expectations. Storminess may change in cluster patterns. The whole sediment record suggests that clusters have happened before. That information can help planners design harbors, choose building sites, and schedule maintenance windows for moorings and channel markers. Knowledge trims risk, it does not erase it. Before the ascent narrative carries the story out, a small blitz of tidy clarifications can serve viewers who love practical details. Visibility here is not guaranteed. Conditions decide. Lights help. Filters on cameras that correct white balance make footage look more like the brain remembers the shallows. Without them, everything skews blue. Shark encounters are usually relaxed. Reef sharks cruise by and carry on. Jellyfish are occasional. Stings are rare and manageable with simple first aid if they occur. Depth gauges can be set to salt water. Small adjustments help accuracy. Dive computers are partners, not bosses. Profiles matter more than numbers on a screen. Snorkeling across the rim is allowed where operators permit. The rule is the same as everywhere. No standing on coral ever. Souvenirs come from shops, not from reefs. Even empty shells are homes for someone when left in place. Sunscreen should be applied well before boarding so it soaks in. Better yet, a long-sleeve rash guard reduces the need. Hydration is not optional under a tropical sun. Water tastes best after a dive because the body asks for it. Now the ascent. The narrative has floated for a while, at a ledge where stalactites point like a choir of silent conductors. It is time to leave them in peace. The path upward is simple and smooth. A reversal of the gradient that brought the descent its mood. The blue brightens shade by shade, and the wall's details reappear in finer resolution. A small school of blue tang flickers left, then right, their tail's precise punctuation in the sentence the reef writes every day. The hydrogen sulfide layer sits below like a page turned, the story of chemistry closing politely as sunlight's chapter resumes. A ray glides overhead near the rim, its wings pushing water with the elegance of a slow heartbeat. The thermometer of skin registers the water's soft warmth, returning in a thin band near the top where the sun's love gathers. The surface when it arrives looks as if someone has laid a sheet of glass on the scene and tilted it slightly. A breath of air greets the face the way a familiar doorway greets a returning walker. Sounds arrange themselves back into their usual places. Voices, a gull's call, the gentle slap under a bow. There is a final image the narrator chooses, because it feels honest. It is not a victory shot or a trophy. It is the rim seen from just below the surface, with the circle outlining a piece of sky. Fish pass along the edge like commuters heading home. The stone looks neither threatening nor fragile. It looks settled. In that frame sits the grounded takeaway. The whole story has been reaching for Earth. Keeps a diary in places like this. Stone, salt, and slow water. And that diary is generous to those who read without tearing the pages. Curiosity brings people here. Responsibility lets them leave it better than they found it. On deck, a guide coils a line. A captain taps a gauge on a fuel tank. Someone laughs at a small joke about parrotfish beach making. The boat turns. The rim slides aft. The circle becomes a dot. Then the dot becomes a memory. And the memory carries forward. The blue hole remains what it has been for a very long time. A vertical portal into Earth's past. A present-day teacher. And a promise that the future can be met more wisely when the past is read with care. The broadcast ends softly, the way a tide leaves a shore. No announcement, just a quiet pull that lingers in the mind.